So it says 1 is a root. First of all, it's odd, right? It's an odd function. So A, B, C, or D, which two can I narrow it down to right off the bat? Yeah.
A and B.
I can narrow it down to A and B, which is 50-50. Which is good on like an ACT, SAT type thing. If they give you something like this, and you can at least narrow it down to 2. 50-50 is better than 25%. All right, it does say that 1 is a root. So what we're going to do is we're going to take synthetic division, and we're going to divide that out. So that'd be 1, -5, 7, -3. Carry down that 1, multiply by 1, -4, -4, -3. Ooh, oh, that's +3. Gotcha. That'd be 3, that'd be 0. It is a factor, but we already knew that. But the whole reason why we did this is because I can now write this as x minus 1, if I could write, x minus 1 times, remember this would be my x squared, my x, my constant, so we'd have 1x squared minus 4x plus 3. Now, more than likely, if it's a problem like this, that x squared minus 4x plus 3 is factorable. So we can go one step further and say, well, this is x minus 1 times, well, we have x. We have to have two numbers that multiply together to give you 3. That's pretty, yeah.
-1 and -3.
-1 and -3. Note we have -1 and -1. So we have two zeros. We have a 0 at x equals 1, and we have a 0 at x equals 3. What's the multiplicity on the one that's x equals 1? Emma? 2. So what happens if multiplicity is 2? Yeah.
It bounces off.
It bounces off. What happens if it's odd? It goes through. So it's going to bounce off at x equals 1, and it's going to go through at x equals 3. So we just have to set up our graph. And we have a 0 at +1, so let's put a point there. We have 1 at 3, so we'll put a point there. We were told that A or B could be possible, so it starts down low, and it approaches 1, and we said because it's a multiplicity of 2, it's going to bounce, and then it's going to cut through. So that most resembles B. The correct answer would have been B on that one. All right, questions on that? All right, then questions on the homework. I don't think we did scatter plots. I think we did and behaviors. Okay. Do you have a specific question?
You said it was like no zeros?
Correct.
I got 10 and 13.
10 and 13 are not zeros.
Can you explain it?
I don't know how you got 10 and 13. Explain how you got 10 and 13, I guess. Did you factor it or something?
I subtracted 10, and then I pulled an x out of the right side, and I got x times x minus 3.
Okay, well, what you have set up right there, so if I hear you right, so we have, you move the 10 to the other side, right?
Yeah.
Equals -10. And then you pulled out an x.
Yeah.
And then you have an x minus 3 equals -10.
Yeah.
Where does that get you, though?
I don't know. I don't know what you're asking.
Yeah. Nowhere. Well, it's not anything mean or anything. It's just the fact that we're trying to find zeros.
Yeah.
We're trying to find zeros. So we need to leave that 0 on the other side, or we need to complete the square. We only have we have 3 methods. We have factoring. So we would see if, so we have x squared. X squared minus 3x plus 10 equals 0. One method is factoring. So I'd look for a number that multiplies together to give me 10 and adds to give me -3. There isn't anything. So that's not going to work. So then our other 2 methods are completing the square, which would involve moving that 10 over there, and putting in the quadratic formula. So if we're doing your method, we'd have x squared minus 3x equals -10, but we need to complete the square. We need to eventually have 0 on one side. So when we complete the square, When we complete the square, we can work on both sides to actually solve for x. All right, there was no way to actually solve for x. You kind of just buried yourself because you had x times x minus 3 equals negative 10. How do I solve for x in that situation? I need to have x equals. Does that make more sense? Okay. So we have three things, either factoring, completing the square, or putting the quadratic formula whenever we have x squared. And if you put in the quadratic formula or you complete the square, you're going to find out it's all imaginary solutions. Okay. What other questions do we have? Okay. Then we'll go over to today's lesson. Well, today's lesson, if you understood this from quadratics, if you understood where I could graph this, sketch a quick graph of it, and know where it's greater than or equal to 0, today's lesson is going to be pretty easy. So we had x squared minus 5x is greater than 0. We said whenever we have a polynomial that is an inequality, what we're going to do is we're going to sketch a quick graph of it. We're going to sketch a quick graph of it, which means first I look at my x squared. Is that going to be a u or an upside down u? It's going to be a u because it's a positive. It's x squared. They both go up, so it's a u shape. So we have a u somewhere. The next thing we're going to do is we're actually find out where the zeros are. Because I plot those 2 points, I make my u, and I can solve for this answer. So we're actually going to go x squared minus 5x equals 0. In this case, Ross, factoring out an x works. Because we would have x times x minus 5 equals 0. Now I can use the zero product property. You can't use that property unless it's 0 on this side. So now that that's 0, we have two zeros. We have x equals 0, and we have x equals 5.
Wait, would it be x is greater than or equal to 0 and x is...
We're just going to find our zeros first. We're actually finding where it's 0. I'm just pretending it's equal to 0 so I can do the graph. So now I can make a quick graph. So we know that it starts high, it's going to intersect at 0 and at 5. 1, 2, 3, 4, 5. Now we have two ways to do this. We know it's a U shape, so it has to look like this. But I can now confirm it because 0 has a multiplicity of 1, and 5 has a multiplicity of 1, so it must cross. But we know the shape of it. It's a U shape, so we know it's got to cross at both of those. All right. Now it's asking, when is that greater than or equal to 0? Just a quick reminder, they're basically asking, when is y greater than 0? Well, y is greater than 0 anything up here. Y is less than 0 anywhere below. So they're looking for everything that's up here. That's that greater than or equal to 0. So on my graph, I'm talking about that leg and that leg there. And we're going to use our x values because the only time you use your y value, and a lot of people got that wrong on the test, the only time you use your y value is for range. Everything else is x values. A lot of you guys missed that up on increasing, decreasing on that first thing. So we got to use our x values. So we're going to go negative infinity to 0. Anytime we have a number, we have to decide if we're going to use a bracket or a parenthesis. What am I using here, a bracket or a parenthesis? Yeah. A bracket, because there is an equal to sign. And we're going to union that. Well, since there's an equal to sign, we'll use a bracket at 5 and to infinity and beyond. So when we have a polynomial with an inequality, our easiest way to solve it is a graph. Some of you try to solve it algebraically and you got like half of it, but the easiest way to do this is by graphing it. It is your most accurate and quickest way to do it. The same thing is going to happen when we have something to bigger powers. When we have something to bigger powers. So let's look down below. It says that we're supposed to solve the inequality x plus 8 times x plus 2 times x minus 3 for when it's greater than or equal to 0. Well, I just want a graph that looks like that to figure out where is it above 0 and where is it below 0. So once again, we're going to do a quick sketch. First of all, our leading coefficient. What power is attached to that? If I multiply all this out, what power would that be? X to the third. Would that be positive in front of it, or would it be a negative in front of it? It'd be positive, because our biggest power would be x times x times x. So that would be a positive x to the third. So in standard form, it looks something like this. X to the third plus something, something, something. I have no idea. I don't need to know that. I just need to know that x cubed. So that means it starts low and it goes high. Now let's look at our zeros. So we're going to do x plus 8 times x plus 2, bless you, times x minus 3 is equal to 0. That gives us 3 zeros. We have x equals negative 8, x equals a negative 2, and x equals 3. Let's make a quick graph of this. So I need a negative 8. 1, 2, 3, 4, 5, 6, 7. Whew, just barely got it. So that'd be my 0 at negative 8. Then we have a 0 at negative 2. And then we have a 0 at 3. So I'm going to start to the left of negative 8. Am I going to start from down or am I going to start from high? So am I starting from down like this or high like this? Down. Yep, we're going to start down because it is x cubed. It starts low, ends high. All right, so I am going to start down here, and I'm going to approach 8. Am I cutting through 8, or am I bouncing off of 8?
Good question.
Mary? We're cutting through it. How do I know that? Because it has a multiplicity of 1. If we look at every one of these are all to the first power. So it's actually going to cut through it, all of them. So we approach 8, and we cut through. We approach 2, we cut through. And finally, we cut through 3. Did I end in the right direction?
Yeah.
There's a good chance I got everything right then. All right, now they're asking, when is it bigger than or equal to 0? Remember, bigger than or equal to 0, they're asking, when is your y bigger than 0? Well, once again, your y is bigger than 0 in quadrants 1 and 2. That's where your y is positive. So I just need to get this little section right here and this little section right here, and we are done. We're going to use x values. It does have an equal to sign, so I'm going to use a bracket. So our solution is going to be from x value of negative 8. That's almost an infinity sign, but not quite. All right, to negative 2, bracket. Union that with 3 to infinity. This is, for my money, the easiest method out there to do this. I'm going to say that because we're going to go through another method to do it, but it's way easier if you just know how to graph it like this. All right, the other method is generally the same, except you have to plug in points to test if it's positive or negative, which seems kind of time-consuming if you already know what it looks like. So our next method is called the test point method. Although drawing a sketch can be an easy way to solve inequalities, sometimes it can be cumbersome. And if you make the smallest mistake, your whole graph could be wrong. The test point method allows us to check each interval individually and does not require you to draw a graph, although it can be easy to do so. So the test point method, you really are still drawing a graph. You really are. You're doing the basics of drawing a graph without knowing how to draw a graph, is basically the test point method. So we're going to solve this exact same thing, but we're going to use something called the test point method. So it says solve the inequality x plus 8 times x plus 2 times x minus 3 is greater than or equal to 0. We know what the answer is, so hopefully we get the same answer. So the first thing is you just need to calculate your zeros. You don't have to worry about multiplicity. You just need to calculate your zeros of your equation. So our zeros are going to be x equals a negative 8, x equals a negative 2, and an x equals 3. Then you're going to plot those on a number line. So we're going to plot that information on a number line. So we're going to just go straight across here. I didn't put anything else weird on there, did I? No. Okay. So we just need a number line. So, and it doesn't have to be super great. So we'll have negative 8. Make sure it has negative, 2 on there. And make sure it has 3 on there. Doesn't have to be evenly spaced. Doesn't have to have zeros or any numbers on it. It just has to be in order from smallest to largest. Now what you're going to do. What you're going to do next is you're going to pick points. You are going to pick points here. You're going to pick a point here. You're going to pick a point here. And you're going to pick a point here. And all you care about is it positive or is it negative? That is all you care about when you plug in. You don't care about the value. You just care if it's positive or if it's negative. So we're going to pick a point right here. We're going to do f of 9. We're not going to spend a whole bunch of time on this because this would be something you just kind of plug in your calculator. If you plug in 9 into this equation, you're going to get out a negative 84. I should move that arrow just a little bit. What was that? Yeah, negative 9, sorry, yeah. If I plug in a negative 9, we'll get a negative 84 out. Which means right here is negative. Because these are zeros, everything here must stay negative. Because it must be coming from the negative direction to get to this 0. Then we're going to test one point here. If this point is positive or negative, the whole section will be negative. What point did I pick out? I picked out f of negative 4. So we're going to check f of negative 4. I got out a positive 56. Does that not work?
It's supposed to be negative.
What was that?
It's supposed to be negative, right?
Why is it supposed to be negative? Let's look at our graph.
Oh, wait, no.
That's right. It should be positive between there. So it's positive there. Yeah, it's the same exact problem. All right, the next point I'm going to pick is something between negative 2 and 3. The easiest one is probably plugging in 0. Because if I plug in 0, it would just be 8 times 2 times negative 3. Really, I just care about it being negative. It is a negative 48, but it is negative. And finally, I have to pick a number bigger than 3. I picked 4. And that equals a positive 72, so this is positive here. Does this look like the graph we drew on the other side?
Yes.
Because we started negative, we went positive, we went negative, and we went positive. In fact, if I was doing this method, I would even do like a little sketch on top of it saying, okay, that's where it's positive, negative, positive. So we're going to get the exact same answer we got on the other side, and that would be from negative 8. Why do I keep trying to do infinity signs? Negative 8 to negative 2 is positive. Union that with 3 to infinity is also positive. Which method's probably easier? Probably the sketch one. But if you forget how to draw a sketch of it, then you can always just check a point between your zeros to see if it's positive or negative. Yes?
So on the homework, do you want us to use this method?
It says to use the test point method. I did use the test point method, but I don't care what method you use. Pick one that you want to use. Pick one you want to use, because honestly, for me, if I was taking a test, I would use just sketch a graph. I mean, it's so much easier to have to check. Here I had to check 4 points, where the other one I just had to do a quick sketch. I'm like, okay, start slow, crosses, I'm done. This is really just a fallback. This is a fallback where I forgot how to sketch something. I need to plug points in instead. All right, questions on that? You know what? Scratch that. At least do 2 of them. At least do 2 of them doing the test point. Any 2 of them, just at least 2 of them do the test point so you know how to do it.